Welcome to 10-minute series lecture. Uh, we were discussing coefficient of consolidation. Now another term is time factor. Time factor. The definition of time factor, rather formula, that is TV is equal to CVT upon D square, where CV is coefficient of consolidation, T is the time for consolidation, and D is the drainage path. Okay, D is the drainage path. See, why we need to find out the time factor? Because when we know the time factor, we can relate it with degree of consolidation. Basically, suppose this is your soil sample, soil, okay, and suppose the water can be expelled out from both the ways. Okay, the thickness is suppose D. So the effective drainage path in this case will be your drainage path will be taken as D by 2, because half of the water, this is your D by 2. Okay, so drainage path is D by 2. Half of the water will move out, will be expelled out in this direction, and other half in other D by 2 distance. Okay, but suppose a rock is underlying soil. So here in this case water cannot penetrate the rock. Okay, this is not allowed. This is not allowed. So water will be expelled out in this direction only. Okay, so here our drainage path will be complete D. Okay, so in this case we have to be very careful while solving such sums. So drainage path in this case will be D. Okay, so time factor TV is equal to CVT upon D square. Here you have to be careful while taking the drainage path. Now regarding degree of consolidation or percentage consolidation, when U is less than 60%, means consolidation is less than 60%, then time factor TV is equal to pi by 4 U by 100 square. Okay, so here you can directly find out the time factor. Suppose if your percentage consolidation or degree of consolidation is less than 60%, you have this formula, and when U is greater than 60%, when U is greater than 60%, we are having a formula TV is equal to 1.781 minus 0.933 log 100 minus U log to the base 10. Okay, so here rather U less than or equal to. Okay, so up to 60% we can apply the first formula, and U greater than 60%, then we can use this formula. You have to remember these formulas. Now next part is regarding settlement, because consolidation ultimately we have to find out the settlement, that is delta H. So the formula is HCC upon 1 plus E0 log sigma 0 plus delta sigma 0 upon sigma 0. Okay, so I have explained you all this terminology. So E0 is initial void ratio, CC we know it is coefficient of compression. Basically coefficient of compression we have seen, it is a slope of void ratio versus stress. Okay, another formula which you are supposed to remember is V1 upon 1 plus E1 is equal to V2 upon 1 plus E2. So there is a derivation also, how we can derive this, but at present derivation is not important. You just remember this formula. The sums, many times they are asking directly the relationship. So V1 upon 1 plus E1 is equal to V2 upon 1 plus E2. So V1 is volume of soil, initial volume, basically initial, and V2 is final volume. Same way E1 and E2 are the void ratio. Another formula which we come across in consolidation chapter regarding settlement, that is SI is equal to QB 1 minus mu square upon E into IF. So here IF will be given to you. IF is basically influence factor. Q, intensity of loading. Mu is Poisson's ratio. And E is Young's modulus. Okay, now remember one thing, to find out CV, that is coefficient of consolidation, we are having two methods. One is square root of time fitting method. Square root of time fitting method. Now the formula remains same, which I told you. The basic formula is TV is equal to CVT upon D square. So here the formula will be same, CV is equal to TVD square divided by T. Now same, this formula will be converted to CV is equal to T90 D square upon T90. Okay, now what do you mean by 90? 90 means 90% consolidation. Okay, so what is T90? T90 is time factor at 90% consolidation. 90% consolidation means only 10% consolidation is remaining now, and small t90 is the time at 90% consolidation. So from the beginning till 90% consolidation, how much time has been elapsed? Okay, and we all know what is D. D is the length of drainage path. Length of drainage path. So just remember, whenever we are talking regarding square root of time fitting method, we will be taking 90% consolidation. Another method is number 2, that is logarithm of time fitting method. Logarithm of time fitting method. Now here the equation remains same, but here we will be taking T50 D square upon small t50, basically 50% consolidation. So T50, can I say it is capital T, so it is time factor. Okay, don't get confused. Small t is related to the time, actual time taken, and capital T is time factor. Time factor at 50% consolidation. And small t50 is time of 50% consolidation. Okay, and remember one thing, they may ask you in your MCQ. Just I am writing down square root of time fitting method is better for soil having higher secondary consolidation. Generally we are concerned with primary consolidation only first stage, but square root of time fitting method is better, okay, for soil having higher secondary consolidation. This is very important. So we can say that there are two types of consolidation. One is primary and another is secondary. Okay, so many times they are asking regarding total settlement. So total settlement will be sum total. Total settlement will be sum total of primary and secondary. In fact, there is one more settlement, that is initial settlement. So I will write SI plus SP plus SS. Okay, SI is related to initial settlement. SP is primary and SS is secondary settlement. Okay, thank you very much.